Okay, hi everyone, welcome back to this video series on data centers. Ethernet at the physical layer. Ethernet was first implemented by a group called DIX, Digital, Intel and Xerox. They created and implemented the first Ethernet LAN specification, which the IEEE used to create the IEEE 802.3 committee. This was a 10 Mbps network that ran on coax and then eventually twisted pair and fiber physical media. The IEEE extended the 802.3 committee to two new committees known as 802.3U Fast Ethernet and 802.3AB Gigabit Ethernet on Category 5, and then finally 802.3AE 10 Gbps over fiber and coax. Figure 3.5 shows the IEEE 802.3 and original Ethernet physical layer specifications. Physical Ethernet 10 base 2, 10 base 5, 10 base T, 10 base F, 100 base TX, 100 base FX, 100 base T4. When designing your LAN, it's really important to understand the different types of Ethernet media available to you. Sure, it would be great to run gigabit Ethernet to each desktop and 10 Gbps between switches, and you need to figure out how to justify the cost of that network today. But if you mix and match the different types of Ethernet media methods currently available, you can come up with a cost-effective network solution that works great. The IEEE, which stands for the Electronic Industries Association and the Newer Telecommunications Industry Alliance, is the standards body that creates the physical layer specifications for Ethernet. The IEEE specifies that Ethernet use a registered jack RJ connector on unshielded twisted pair UTP cabling RJ45. However, this is just called an 8-pin modular connector. Each Ethernet cable type that is specified by the IEEE has inherent attenuation, which is defined as the loss of signal strength as it travels the length of a cable is measured in decibels dB. The cabling used in corporate and home markets is measurable in categories. A higher quality cable will have a higher rated category and lower attenuation. For example, category 5 is better than category 3 because category 5 cables have more wire twists per foot and therefore less crosstalk. Crosstalk is the unwanted signal interference from adjacent pairs in the cable. Here are the original IEEE 802.3 standards. 10 base 2, 10 Mbps baseband technology up to 185 meters in length, known as TiNet, and can support up to 30 workstations on a single segment. Uses a physical and logical bus with BNC connectors and thin coax cable. The 10 means 10 Mbps, base means baseband technology, which is a digital signaling method for communication on the network, and the 2 means almost 200 meters. 10 base 2 Ethernet cards use BNC, British Naval connector, bayonet nail, console man and bayonet nut connector, T connectors and terminators to connect to a network. 10 base 5, 10 Mbps baseband technology up to 500 meters in length using thick coaxial cable known as ThickNet. Uses a physical and logical bus with AY connectors up to 2,500 meters with repeaters and 1,024 users for all segments. 10 base T, 10 Mbps using category 3 unshielded twisted pair UTP wiring for runs up to 100 meters, unlike with 10 base 2 and 10 base 5 networks. Each device must connect into a hub or switch, and you can have only one host per segment or wire. Uses an RJ45 connector, 8-pin module connector with a physical start topology and logical bus. Each of the 802.3 standards defines an AUI, which allows a 1 bit at a time transfer to the physical layer from the data link media access method. This allows the MAC address to remain constant but means the physical layer can support both existing and new technologies. The thing is the original AUI interface with a 15-pin connector which allowed a transmitter receiver that provided a 15-pin to twisted pair conversion. There's an issue, although the AUI in interface can't support the 100 Mbps Ethernet because of the high frequencies involved, so 100 base T needed a new interface, and the 802.3u specifications created one called Media Independent Interface MII, which provides 100 Mbps throughput. The MII uses a nibble, which you of course remember is defined as 4 bits gigabit Ethernet, uses a gigabit media independent interface GMII and transmits 8 bits at a time. 802.3u fast Ethernet is compatible with 802.3 Ethernet because they share the same physical characteristics. Fast Ethernet and Ethernet use the same maximum transmission unit MTU and the same mechanisms, and they both preserve the frame format that is used by 10 base T Ethernet. Basically, fast Ethernet is just based on an extension to the IEEE 802.3 specification, and because of that it offers us a speed increase of 10 times that of 10 base T. Here are the expanded IEEE 802.3 standards, starting with fast Ethernet 100 base TX IEEE 802.3u, 100 base TX, mostly known as fast Ethernet, uses EIA TIA category 5, 5E or 6 UTP 2 pair wiring, 1 user per segment up to 100 meters long, and it uses an RJ45 connector with a physical start topology and a logical bus. 100 base FX IEEE 802.3u uses fiber cabling 62.5 125 micron multimode fiber point-to-point topology up to 412 meters long. It uses ST and SC connectors, which are media interface connectors. 1000 base CX IEEE 802.3Z copper twisted pair called Twinax, a balanced coaxial pair that can run only up to 25 meters and uses a special 9-pin connector known as a high speed serial data connector HSSDC. 1000 base T IEEE 802.3AB category 5 4 pair UTP wiring up to 100 meters long and up to 1 Gbps. 1000 base FX IEEE 802.3Z, the implementation of 1 gigabit Ethernet running over multimode fiber optic cable instead of copper twisted pair cable, and using short wavelength laser multimode fiber MMF using 62.5 and 50 micron core, uses an 850 nanometer NM laser and can go up to 220 meters with 62.5 micron, 550 meters with 50 micron. 1000 base LX IEEE 802.3Z single mode fiber that uses a 9 micron core 1300 NM laser and can go from 3 kilometers up to 10 kilometers. 1000 base ZX Cisco standard. 1000 base ZX or 1000 base ZX is a Cisco specified standard for gigabit Ethernet communication. 1000 base ZX operates on ordinary single mode fiber link with spans up to 43.5 miles 70 km. 10 gig base T is a standard proposed by the IEEE 802.3 AN committee to provide 10 Gbps connections over conventional UTP cables category 5E6 or 7 cables. 10 gig base T allows the conventional RJ45 used for Ethernet LANs. It can support signal transmission at the full 100 meter distance specified for LAN wiring. 10 G base short range SR, an implementation of 10 gigabit Ethernet that uses short wavelength lasers at 850 nm over multimode fiber. It has a maximum transmission distance of between 200-300 meters depending on the size and quality of the fiber. 10 G base long range LR, an implementation of 10 gigabit Ethernet that uses long range wavelength lasers at 1310 nm over single mode fiber. It also has a maximum transmission distance between 2 meters and 10 kilometers depending on the size and quality of the fiber. 10 gig base extended range ER, implementation of 10 gigabit Ethernet running over single mode fiber. It uses extra long wavelength lasers at 1550 nm. It has the longest transmission distance possible of the 10 gigabit technologies, anywhere from 2 meters up to 40 kilometers depending on the size and quality of the fiber. 10 G base short wavelength SW. 10 G base SW as defined by the IEEE 802.3 AE is a mode of 10 gig base Fs for MMF with an 850 nm laser transceiver with a bandwidth of 10 Gbps. It can support up to 300 meters of cable length. This media type is designed to connect to SONET equipment. 10 G base long wavelength LW. 10 GBLW is a mode of 10 base L supporting a link length of 10 km on standard single mode fiber SMF G652. This media type is designed to connect to SONET equipment. 10 G base extra long wavelength EW. 10 G base EW is a mode of 10 base E supporting a link length of up to 40 km of SMF based on G652 using optical wavelength 1550 nm. This media type is designed to connect to SONET equipment. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.